Hello to everyone. I am Professor Raja, working as Assistant Professor, EC Department, SNS College of Technology, an autonomous institution, Coimbatore. In this YouTube video, I am going to discuss the 19 ECEB 301 Analog and Digital Communication subject under Unit 4 Digital Modulation Techniques under the topic Amplitude Shift Keying. So based on my previous YouTube video, you may have some knowledge about what is meant by modulation, how the analog modulation are done, and the various classifications of analog modulation, that is amplitude modulation, frequency modulation, phase modulation, everything already discussed. If you have any doubts regarding this, you can watch my previous playlist. Now in this unit 4, I am going to discuss the digital modulation techniques. So digital modulation means all the modulation output are under the type of digital output only. Now I am going to discuss the amplitude shift keying. So digital modulations are basically three types. One is called analog amplitude shift keying, second one is frequency shift keying, third one is the phase shift keying. Both amplitude shift keying and phase shift keying are combined together to call the name called quadrature amplitude modulation. Now amplitude shift keying. Amplitude shift keying or on-off keying is the simplest digital modulation technique. In this method, there is only one unit energy carrier and it is switched on and off depending upon the input binary sequence. The ASK waveform can be represented as S of t is equal to root 2 ps cos 2 pi f naught t, where if we transmit the data of 1, if we transmit the symbol 0, then S of t must be 0, that is there is no signal is transmitted. S of t contains some complete cycle of carrier frequency f. Thus for ASK, if symbol 1 is transmitted, then the pulse is occur. If symbol 0 is transmitted, then there is no symbol is transmitted. Now we will see the graph of this ASK. If you see, the subdivision 1 shows the digital bit sequence 10101001. The subdivision 2 shows the carrier frequency which is in the low frequency of sine waves. If you see the third one, that is ASK modulation, whenever the digital bit sequence is 1, that time only the data is transmitted. If 0 means there is no data is transmitted. That is why it is called as on-off shift keying. Now I am going to show the another example of this one. So already I told, for 1 the data is transmitted, for 0 there is no data is transmitted. Signal space diagram of ASK. The ASK waveform of equation symbol 1 can be represented as S of t is equal to root 2 ps tb into root 2 by 2 tb cos 2 pi f naught t, or simply pi 1 of t is represented as root 2 by tb into cos 2 pi f naught t. So finally S of t is equal to root 2 ps tb into pi 1 of t. Therefore the distance between two orthogonal points should be calculated as d is equal to root 2 ps tb, or simply it is the root eb. Next, generation and coherent reduction of ASK. The above figure shows the ASK generator. The input binary sequence is applied to the product modulator. The product modulator amplitude modulates the sinusoidal carrier. It passes the carrier when input bit is 1. It blocks the carrier when input is 0. Simply, if you see the diagram, the binary bit, that is the digital input, is given in binary sequence of B of t. Then the carrier is given at the downside, that is root 2 ps cos 2 pi f naught t. Both are multiplied together in the name called product modulator. Then finally the binary ASK signal should produce the combination of B of t into root 2 ps cos 2 pi f naught t. So this is the diagram shows how an ASK will be generated. So as I told earlier, the carrier wave will be generated the low frequency wave. The binary data sequences are given input. Then both are multiplied together in the product modulator. Then we get the ASK waveform. Next I am going to discuss the generator of ASK. It consists of a signal generator that produces a high frequency sinusoidal waveform, that is a message signal in digitized form, and a band pass filter. The switch provided here gets open and closed according to the bits of the message signal. When The digital bit is of level high, that is 1, then the switch gets closed. Thus allows a carrier wave to get transmitted. As against in case of low level, that is a bit is equal to 0, the switch gate opens and restrict the carrier wave. That is, this is the reason why the signal appears at the output in case of high. After this, a pulse replacing is done by the band limiting filter according to the amplitude and phase characteristics of the filter. Now we are going to see the detector or receiving part of the amplitude shift key. Detection or demodulation is the process of recovering original message signal from the modulated waveform. So in this YouTube video, I discussed the what is meant by digital modulation techniques and what are the various classifications of digital modulation techniques, and I discussed the amplitude shift keying generator circuit diagram. Next YouTube video, I am going to discuss the digital detector or demodulation in ASP. Thank you for watching my video.